Hi, I'm Katie Steckles.
And I'm Peter Rowlett. And hi Katie, what's today's mathematical object?
Today's mathematical object is fingers. And because I don't know enough about fingers to talk about them competently, I've brought along a special guest. So please welcome Ben Orlin.
Yeah, hi. Yeah, thanks for having me on. I'm glad to bring my special expertise in having hands.
Yep.
It's decades I've been studying for this, so I'm really quite excited for this podcast moment.
Excellent. So we've brought Ben to talk about fingers, which is secretly, it's one of those times when we've picked an object that just gives us a good excuse to talk about a bunch of interesting things. But I think this is quite a nice one, actually, because there are a lot of connections between like fingers and humans and the way they interact with the world and stuff like that, I guess, right?
Yeah, I think arguably the first mathematical object, right? I mean, I don't know, I wasn't there 80 or 100,000 years ago, but like, you know, people point to the Inchango bone and all these like old artifacts that we have as the earliest mathematical objects. But really, like, I don't know, we found old finger bones. Those are mathematical.
Yeah, well, I'm imagining like the first person who ever counted anything using their fingers to count. I don't know why, because there's no reason why you would do that, but it just feels like such a natural thing.
It's nice to have something to keep track of. I have a 2-year-old right now, and seeing her, like, she knows lots of numbers, doesn't always remember three. Just she skips right past it, which is funny because she's about to turn 3, and you'd think that would feel pertinent to her, but not so much. No, I mean, counting is, I don't know, it's philosophically subtle stuff.
I feel like that would be a sort of just rule that you can only count up to your age. Like, you only learn to count up to numbers that you've had a birthday off.
My son has a plan that schools should teach the times table of the year the school year is.
Oh, wow.
So because he's in year 2, he should be learning the 2 times table and then do the 3 times table next year and the 4 times table the year after that.
That sounds good. I thought you meant the year 2022. And it's going to be all the way up to 2021 times 2022. That's going to be a tough times table.
Yeah. But no, there's a whole thing with counting, isn't there? Because there's a phase where you just learn the numbers as a sort of rhyme. And so kids will like tap objects because they know that the objects somehow relate to the thing, but they don't really tap them in one-to-one correspondence with the thing that they're saying. So they'll count 6 things, but they'll count to 10 while they're tapping them and things like that. And then it sort of develops, doesn't it, that you start to understand.
My favorites are the ones where they manage to make multiple errors that cancel out. So my daughter will be tapping several things, skip 4 and 5, tap a couple things twice, and wind up correctly having counted 7.
Right.
It's like, I don't know if I can give full marks for that.
Do you want to encourage that? Like, do you want to praise that when it happens? Or?
Yeah, I mean, I think yes is the answer, because the fact is, like, she's going to learn to count. I'm not too worried about it. I don't think this is one where she needs, like, really focused feedback to get there. Like, you know, give her another year or 2 and she's gonna master it. So just a lot of excitement that she's engaging with numbers is fine at this age.
My little nephew's like 3, nearly 4 now, and he's able to read numbers, but he can't do 2-digit numbers yet. So we were in the restaurant the other day and he's like, the table number is a 5 under 1. Like, yes, it is. Amazing. Soon you will develop, you know, what that is, but for now that is perfect. Great.
Yeah.
Can I read my Aristotle quote?
Yeah.
I want to go in because you were saying fingers. We were picking because there's lots of interesting mathematical ideas. To me, I picked the topic just because I like being able to dunk on Aristotle. And to me, this is, I mean, there's a lot of stupid Aristotle quotes. Like there's one where he really insists that flies have 4 legs. I think he makes a real point of it. It's like it's important to him. That's a building block in an argument that flies have 4 legs. But this is one where he's like trying to figure out why people use base 10. And he's speculating, he's throwing all these reasons out there. So he writes, why do all men, whether barbarians or Greeks, count up to 10 and not some other number? Which, first of all, I mean, I guess we can't blame him for not being an anthropologist, but like there are definitely lots and lots of languages that are not base 10.
Yeah.
There's like, you can pretty much name a number smaller than that. Like you'll find a language out of base 2, base 6, base 4. Like there's lots of them out there. And then he writes, let's see, or why again do they not stop at some number beyond 10 and then repeat from that point? Which, like, again, is wrong. Mayans used a base 20 system. Babylonians use base 60.
Yeah.
Like, it definitely, so far, not so good. But then he says, chance cannot account for the fact that apparently everyone does this always. So then he starts to list some reasons. And he's like, is it because 10 is a perfect number, seeing that it comprises all kinds of number, even and odd, square and cube, linear and plane, prime and composite?
Is it like up to 10, we've got at least one of each of all of those, maybe?
Maybe. How is 10 even and odd? That doesn't
Yeah.
make any sense. You could also say, if you go up to 2, you've already hit an even number and
And
an
a
odd
prime,
number.
yeah.
Like this, and a prime, yeah, right.
And
Yeah,
square.
you've really got a, yeah, right. You've got a square number. Yeah, right. 2 would really cover a lot of the ground. But he's really, like, or is it because 10 is the beginning of number, since 10 is produced by adding 1, 2, 3, and 4? That's not the beginning, Aristotle.
Yeah, but have you met 6? Like,
Right, six would really cover a lot of the same ground. So with 3, and then he keeps going. He's like, is it because moving bodies are 9 in number? I guess he's counting the 7 planets of which they were aware, plus the sun and the moon. Is 7 right? No, I guess the moon needs to be. Wait, I'm not even sure because they didn't. They were missing Neptune and Uranus, so we're down to 6. I don't even know where he's getting 9. And why would that give you 10 anyway? Anyway, so Aristotle, and then finally at the very end, he's like, or is it because all men had 10 fingers? It's like, yes, Aristotle, that last reason that you finally got there is the 10 fingers thing.
Yeah.
So right, which gives us, I mean, mathematicians love to complain about the quirks of base 10. It's like really not, you'd probably pick base 8 or base 12. I think if you were looking at our cognitive capacities and trying to pick something that was going to make for nice notation and easy divisibility rules and all that.
There's a whole gang, right? There's the whole society of dozenalists who are keen to switch to base 12. And it's not clear how they're planning to do that or how easy they think that would be, but
yeah, I can't tell if that's just a lark for them or if they're really this is like their.
We just pick a day, like the 12th of December, and just be like, from this day.
Right, like that day that Sweden switched sides of the road. Right, they used to drive on the British side, now they drive on the American side.
Yeah. Everyone just politely pulls over and starts counting in base 12. Yeah.
Exactly. Right. Yeah. Just all right, everybody, wave a flag, and now we're in base 12.
I'm thinking about dates before they switched calendar, right? There's sort of a date before which it's like, oh yeah, but that was under the old calendar, not the new calendar. You'd have to be like, yes, I know it looks like it says 14, but that was before they switched.
Yeah.
You know, just make it so hard.
It also would have the problem that I think kids already kind of struggle to memorize times tables, right? It's like, it's arguably pretty useful to have some multiplication facts memorized. If you go from 100 facts to memorize up to 144 facts to memorize, it's actually a lot more. Which would be a good argument for base 8. Just shrink the times tables.
Although we did actually learn up to the 12 times tables. And I think we did go up to 12 on each one.
I think kids here learn up to 12.
Maybe, because in base 12...
Okay, fair enough.
I guess, would you stop at 12? Would you still call it 12? I guess? Oh, God, there's so many things to worry about. And you need to grow the extra 2 fingers as well. So.
Yeah, right. So like... Yeah, right. Yeah, that's true. Yeah, right. Oh, this actually brings, so there's different counting systems, right? We sort of think of it pretty naturally. You have 10 fingers. We all use base 10. But there are different ways to count on your fingers. So apparently in a lot of parts of Asia, what they do is they use the thumb as kind of a like highlighter for different knuckles. And what you do is you count along your knuckles. And so you have 3 points that you're tapping along each finger. So, like, you tap, I guess there's, like, the lower knuckle and then the middle knuckle and then the tip of the finger.
Oh, like, sort of between the creases on I'm trying to do this on the outside and it's too difficult, so on the inside of my hand.
Right. Oh, yeah, no, yeah. Yeah, that would take a very flexible thumb. Along the inside of the hand. So you tap the creases. Yeah, creases is a better way to put it than knuckles. And so you kind of get 3 taps per finger for each of 4 fingers. And so you can count to 12 on one hand.
And that's sort of nicely divided into 4 as well, so there's sort of a granularity to that as well. Like you can sort of tell how far through the 12 you are quite easily. Yeah, it's 4
groups of 3, and then very cleverly they'll also use the left hand or the other hand to track how many 12s you've counted so far.
Yeah.
So actually just like that, you can get up to 144 on your hands, which is pretty good. That's better than I tend to do.
I'm always fascinated by these like different systems that people use in other countries because you sort of just accept that what you're doing and what everyone around you is doing is normal, and then you just hear that like in other countries, they don't count. Like the thing about starting counting with your thumb instead of your first finger. Because I had this in a place. I ordered 3 coffees, and I start counting on my thumb, and I don't know why I do that. Because apparently, where I'm from, it's standard to start counting on the first finger.
Oh, really?
But I put my thumb, my first finger, my second finger, and then I held up 3 fingers, and the person just looked and saw that I had 2 fingers up and made 2 cups of tea. So I was like, no, I've got my thumb out as well. Like, what's wrong with you? They're just 3. And because everyone's wearing a mask and it's loud and no one can hear what you're saying, so they're really relying on that. And I was like, no, I did ask 3 coffees. Oh, nightmare. But yeah, it's like, I saw a thing on Twitter today about tallies. You know, when you write a tally where you put 4 vertical marks and then you put a horizontal
4 lines,
one
then cross it. Yeah.
Apparently in some places, including like France, which is very close to here, they do a square. So they draw the 4 sides of the square and then put a diagonal across it, and that's 5.
Mm-hmm.
And I'm just like, I can't even conceive of that. But there's like people who, work in France who start drawing a normal tally, and everyone's like, what are you doing? Like, that's weird. But yeah, it's just different systems, right? It's sort of evolution of maths, and it gets into that sort of Platonist, like, invented or discovered. Like, everyone has their own approach to this thing, but they're all kind of encoding the same actual facts.
Yeah, it is funny that the tasks are so similar that, like, different people come up with, everybody needs a tallying system, right? Like, we're all counting stuff, and yet you come up with different ones. To be fair, the square is probably better, as I think about it. Right? Like, I don't know, like, glancing at 3 and 4, I guess my eye can kind of immediately parse that. But easier to look at a complete square or an incomplete square and tell.
I think that's the reason for tallies being groups of 5 as well, because I think there's been science, I don't know, I wasn't there, but that like the number of objects that you can recognise in a group just by glancing at it is something like up to 5, like as a human.
Yeah, I think this is a cognitive science literature that I have, like, looked at the names of the papers in. That's the extent of my familiarity. And I think it tends to be 4 is what most people can do.
Right. So if you can do 4, then you put a line across it, that's a 5. And then you're on the next one.
Right, because we're pretty good at spotting lines across things. That goes well. Otherwise, like, no smoking signs would not do very well.
This was part of the discussion under the tally thing, because they were like, why do we do groups of 5 for tallies? Because I guess you could do more, but it's probably partly that and partly the 5 fingers on a hand thing.
Right.
Like, that's just like a standard reasonable quantity of stuff.
Yeah, I guess it's a nice thing that we happen to get a hand that has not too many fingers on it. Imagine if we just, like, couldn't keep track of the fingers on our hand in one glance. If it really took some counting to total them
maybe
up.
That's why.
Right. It's just funny to think that our cognitive constraints would be putting limits on what. I mean, I suspect it's something more about dexterity. But when I was little, actually, this is like on our fingers theme, my father, who's a mathematician, would play a mathematical trick on me. Later on in my childhood, he would play subtler tricks, but this one was when I was, I don't know, maybe 3 or so. He would hold up his hand and be like, "Can you count the fingers?" And I would count them all. I'd say 5. And then he'd take his hands and kind of wave them together and wiggle them so all the fingers were looking like they were getting all mixed together. Just like basically rubbing his hands together. And then he would hold up the hand again and say, "Now how many fingers?" And I was so disappointed. It was always 5 again. He never changed it. I thought once maybe he would go for 7 or 3. Like, he would mix around the fingers enough and move some to the other hand.
Yeah.
And the trick is that you would count them again one by one.
I would count them again and be disappointed because he hadn't. It was like he showed me part of a trick, but he hadn't really followed through. He was just, it was a bait and switch.
That's amazing. Yeah.
One thing, my son is obsessed with dinosaurs, and I hadn't realised how many. I sort of think that creatures on this planet, I don't know, often have like 5 digits on the end, but dinosaurs are all sorts of numbers.
Yeah.
There's no sort of pattern to it, because dinosaurs are like millions of years and massive amounts of evolution. And so he's like, that dinosaur with two fingers. And I'm like, what?
Yeah.
What do you mean?
I'm trying to remember. I think this was actually one of the Only Connect questions that we didn't get when we were on Only Connect, just to throw that into the conversation in case anyone didn't know this. My team won the Series 15 of Only Connect a couple of years ago. And
I thought you were trying to drop in that you failed to get a question on it.
We did. This is me being self-effacing when we won the entire series. But anyway, the question was, it was like a series of things, and you had to say something that would be 4th in the series. And the things that they gave were an animal that has 2 toes on each foot, an animal that has 3 toes on each foot, an animal that has 4 toes in each foot. And we didn't even realise that's what it was. They were just the names of 3 random animals. And I was like, I don't know, a lion? And then because lion was one of the labels on the question, so it's just like, let's name an animal. There's a picture of a lion on the wall. Let's go lion. And the presenter was like, why? Like, specifically why? And I was like, I don't know. And she's like, right, well, if you'd said because lions have 5 toes on their back feet, you would have got the mark. But you didn't say that, so no. And I think it was. I might have been misremembering, but it's something like they've got 5 toes on the back feet and 4 on the front feet. So it turns out it was almost a right answer. And if I'd said lion because they've got 5 toes on some of their feet, we would have got a mark. I'm furious. I'm not going to answer why. You know if it's right or not.
This is a good show your working moment, isn't it?
But, yeah. So we've got you on the podcast, Ben.
Right.
Using fingers as our object. as a good excuse to talk about things, but you actually have a
Right.
really good reason why you want to talk about
That's
fingers.
true, actually.
Right?
Yeah. So I've got this book of mathematical games that was just published, and right, you've both seen it and both presumably broken a limb or two on trying to lift it.
Yeah, it's massive. It's
big.
absolutely massive. I just had to not swear on the podcast. It is absolutely beep.
It's really bigger than I thought it would be.
Honestly.
Yeah. Yeah, I feel like my British acquaintances and friends are much more willing to just be really blunt about that. Like, Americans like, oh, wow, yeah, thanks for the book. It looks nice. And every British person I've sent it to is like, this thing is enormous. What?
I feel like we're sort of slightly overdoing the joke on that it's like 360 odd pages. It's not like when you say this book is massive. It's not like a 1,000-page book or something.
No,
it's actually massive.
It's just physically
it's not like an encyclopedia, right? No, it's a nice length. There's a lot of games in there, but it's just the dimensions of it are large. It's a heavy cover. It'd be certainly a good murder weapon. I don't recommend using it that way, but.
When it arrived, I was like, oh, 3 books have arrived. And then I opened the parcel. It was just the one book. But it sort of works because there's a lot of detail going on. There's a lot of like illustrations around things. And it's just a really nice object.
Yeah, no, I really like my publisher. They just make good objects. It's just good production value on the book. But some of the games in there are finger games.
Yes. Sorry, back on topic.
Yeah, right. Yeah. So one of my favorites, actually, I came across this. I was just researching. I did lots and lots of reading around to find games for the book. I found this one that I thought was this like fun, quirky game that I'd never heard of called Chopsticks, where you sort of hold out fingers and then tap each other's fingers, and that adds more fingers to your hand. And I was teaching an 8th grade class at the time, so I brought it to them to teach it to them at like the end of a lesson. We had a little free time, and I started explaining it as like this exciting new game, and they started out excited, and then their faces all just fell. I'm like, oh, you mean sticks? And every single kid in the class had played this game like for several years. Like it was a very familiar game to them.
And I read this. This is not a cultural difference. I read this in the book. It's because we're old. That
Yeah,
right.
Yeah.
Oh, okay.
It's very specifically because we were in middle school and elementary school, sort of after or before 2002, 2003. Because basically the game I was emailing with a games expert in near Barcelona, and he was saying it was the same thing. Like his kids learned that game around 2003, 2004. So it was probably played in Japan, we think, maybe through the 90s. It was just like invented by kids playing in the schoolyard, and then had this kind of sudden global spread in the early 2000s. And now is a totally ubiquitous hand game that like you talk to a 11-year-old, they'll probably know it. You talk to a 31-year-old, 41-year-old, they will probably not.
Wow. I was always feeling really smug about like all the stuff I know that kids don't know. Like when you go to the quiz or something and they're just like, who's that? And I'm like, come on. That's a celebrity that was dead before you were born. Surely you know who that is. But yeah, this is them getting their own back, right? They've got their own stuff.
Well, and then also you see the foot of a lion, and who knows how many toes a lion
like,
has.
What's that?
Again,
yeah.
Kids are right. Yeah. What is that? Part of the animal. So Sticks. Have you guys played this game now? Have you seen the?
I've not made it to that page in the book.
Okay. Fair enough. Yeah.
I'm still in the process of lifting the front half of the book upwards. I've got some wedges under it now. Tomorrow
calling a friend. Yeah, that's right. Yeah. If you just develop a pulley system, you can get it open in just a day or two. But the game has a nice connection to modular arithmetic, because what you're doing is you start with everybody holds up one finger on each hand, and then you tap someone else's hand. And so if I tap one of your hands, now I've added a finger to it.
Okay.
So you're at 2 on that hand.
Yeah.
Now you take your 2 fingers, maybe you choose to tap one of my hands. That adds 2 to my hand, so now I'm at 3, and we keep going like that. And
I'm sensing this is going to run out at some point. This is going to become a problem.
This is right. Yeah. Right. Oh no! Do you only have 5-fingered hands? Oh, okay. Yeah. You're not going to be able to play this at a very high level.
Yeah.
So now I take my 3-finger hand and tap your 2-finger hand.
Yeah.
That goes up to 5. But we're playing mod 5. So what happens is 5 is equivalent to 0, so that hand basically vanishes.
Right.
But if you had gone over, so if you had 3 on your hand and I tapped it with a 3, then that's up to 6. So we subtract 5, you're down to 1.
Nice.
So what I like about this is some Japanese school kids in like 1992 just, came up with modular arithmetic because they had hands and they were in a schoolyard and they wanted to play a game. And that was, you can't just keep going up indefinitely on hands. You've got to loop around.
That's really nice.
Yeah, there's something. Yeah, right. Yeah, you just you've got some equipment around. That equipment is your 2 hands, and you go ahead and play.
Incidentally, obviously, if anyone's listening to the podcast, you couldn't see that I was literally doing all of that along with, but I'm definitely sure that people listening will have been doing that along with, hopefully. Or if not, rewind it and go back through and just do it along with using your hands. It was great.
Right. I'm hoping the people driving maybe are hopefully being careful about taking both hands off the wheel. And those on public transit, I'm picturing being like very surreptitious about trying to like play with their fingers without drawing too much attention. Like, I'm listening to a counting podcast. They're teaching me how to count.
You could just pretend you're like doing your taxes or something in your head, like you just for some reason tapping one hand with it so often.
That is how I do my tax. It's funny to think that like I would be doing my tax in my head, and really the limit on my working memory is I just need to hold up 3 fingers. Yeah, and that would be the thing that would help me keep track of it.
This year I need to pay 3 taxes. Yeah. Yeah, but is there actually, because I say I've not made it to that point in the book yet, there are some really nice games in the book. It's like, there's 75 and a quarter games in the book. Is that right?
There's 75 and a quarter games, yeah that's right. Yeah.
And I've sort of thought about going and looking for the quarter of a game, but apparently it's not quite like that.
Yeah, I decided I wanted to make it maximally strange. So, like, if I just counted every game and every variation, I think I would have gotten 150.
Right.
And bizarrely, I didn't do this until afterwards. It would have been exactly 150, which is a nice round number, and maybe I should have gone with that. But instead, what it is, I counted, there are games that are sort of featured in some depth in the book, and so I counted those as one game. And then there are games that are only get about a paragraph. So I gave a discount on those. Those are 11/12ths of a game.
Right.
And then there are games which are variations on the existing game, which are, like, change it pretty substantially, but are still recognizably the core game.
Yeah.
So I counted those as a quarter of a game. And then there are very small rule variations, like in Chopsticks, there's different ways you can play. Sometimes you can transfer your fingers from one hand to the other. So I counted each rule variation, like minor rule variations like that, as 1/57th of a game. That's
right. Reasonable. Yeah.
And that added up to 75 and a quarter.
I mean, I can't argue with that. That seems like a good system. Yeah.
Yeah, right. I can't argue with that as my favorite phase for things too illogical to argue with. Like, there's no arguing with that. It would need to have a premise or some kind of logic to it to argue with it.
But yeah, so I guess there'll be other finger games in the book, right? This is because there are a lot of like really low key, like pen and paper, like really simple things that you don't need much equipment for. But the finger games are the ones you can just play if you've forgotten to bring anything with you, right?
That's right. Yeah, anything except for this giant book.
Yeah. Obviously.
Yeah, exactly. Right.
Well, there's no space for anything else in your backpack, so you've just got the book.
Just clutching this book in your fingers. So the majority of the games are pencil and paper, but there are some other nice finger games too. There's some sort of variations on rocks, paper, scissors. So there's the one that became famous for being on The Big Bang Theory. It has 2 extra gestures.
Yep.
I like that one. I also reference, but do not include the rules for one that has, let's see, I guess an extra 98 gestures.
Nice.
Because you can play rock, paper, scissors, a variation on it with any odd number of gestures. So someone went through and designed one with 101 gestures, which means you need 101 choose 2 rules for which gesture beats which one.
Yep. Wow.
So that's a hand game with 5,050 rules to memorize.
And is it still non-transitive?
Yes, I think it has the property you want that each gesture, right, for any 2 gestures, you can find a third gesture such that it's isomorphic to rock, paper, scissors.
All right, so there's subsets of it that are rock, paper, scissors in there. Oh, that's nice.
Yeah, that's definitely how... that may not suffice to completely induce the structure, but basically, what it is you want... So you can kind of draw a circle diagram where you draw all your gestures in a circle, and each gesture ties to itself, beats the next 50 in the circle, and loses to the prior 50 in the circle.
Right.
And you can just kind of use that to get the structure of your game.
Just look it up on the diagram. As a simple handy reference.
It's like also rock, paper, scissors. You can come up with pretty natural. It's like the weird one is paper beating rock. Like I don't know why. It's like the rock is covered.
It's covered up. Yeah.
Right. Defeated forever.
Do? Yeah.
that paper will outlast that rock now.
Yeah. I just imagine the rock's like, oh no, I'm being given as a gift. Like, yeah.
Right. Devastating outcome. Whereas when you go up to 101 gestures, now you need, first of all, 101 things you can make with your hands that are recognizable. And then you also need rules for which one beats which other one. So I include 1 or 2 examples in the book, but it's sort of like vampire defeats baby. Actually, maybe baby. No, I'm sorry. It's the other way around. Baby defeats vampire because the baby becomes vampire. Right. I guess. And then there's one in the middle. that vampire defeats, but then that in turn defeats baby. It's a very weird set of rules. I'm impressed with the person who came up with that.
Yeah, I feel like you'd have to like go to the people who designed sign language, because I imagine that's just like a small group of people. But yeah,
right, or pick a sign language.
but
Right, yeah.
one of the sign languages, and like use that because they'll have distinctive symbols for different things. But
Yeah, I have no idea how many different sort of, I guess you wouldn't call them phonemes, but hand names there are.
could it just be? It's like a really sneaky way to teach someone sign language. I'd be like, we're going to learn this game, and you actually just learn 101 words in sign language.
All right. We've been playing rock, paper, scissors with 17 gestures. Now let's go up to 19. I'm going to have the gestures for S and cat.
Yeah. Yeah. Hello beats, dinner. Like, just useful words.
Right. Right. Hello comes before dinner. I mean, the advantage you have in writing rules is you can always throw a verb in there, right? Paper covers rock.
Yeah.
Rock smashes scissors. Yeah. Scissors cut paper. So, right, the classic one, the 5-gesture version is actually relatively playable. That brings in Spock, which is the classic Star Trek gesture with the fingers together, and Lizard, which is just like a little lizard mouth.
Yeah.
And then the lizard poisons Spock. The paper disproves Spock.
Oh, nice. Yeah.
Spock, I believe, vaporizes the rock, and Spock just breaks the scissors, which seems easy enough.
Yeah. Yeah.
So anyway, that's another fun hand game. And then one that I really like is called Undercut, where you just hold up it's like rock, paper, scissors. So you sort of 1, 2, 3, go. Hold up a number of fingers. That's just the number of points you get. So far, a pretty minimal game. Not a lot.
Yep.
I held up 4. I get 4 points. I held up 5. I get 5 points. I won. 5-fingered people will generally hold up 5. But then the rule that makes it interesting is if you hold up exactly 1 finger less than I did, so you hold up 3 and I hold up 4, then you steal my points. So you get 7.
Ah.
So what you want to do is you want to hold up more fingers than the other person, but 2, 3, or 4 more fingers than them, not 1 more.
Yeah. Oh, there's some quite nice game theory in there, like trying to predict what they're going to do. Because is there like an optimal strategy or?
Yeah, so it's a classic like 2-player 0-sum game theory problem. Douglas Hofstadter was the one who devised this game with a friend and then wrote about it. And so he was very proud. He developed this little computer program. He was, I think, a computer grad student in the 70s. And so he developed this little computer program that looked at your last 5 numbers that you picked, and then would make a prediction based on, I guess, you sort of were playing against another computer program. Once it had, a few hundred games of evidence, it could then predict pretty well what you would pick based on your last 5 gestures. It would just kind of do a search for, well, what did you do in the past when you made those gestures?
Wow.
And so his beat pretty much everybody it played until someone came along and just did the elementary game theory to solve for the optimal strategy, which is just totally random, right? It's like rolling a 66-sided die and then picking 5 1/66 of the time and picking 4 some fraction of the time. And so you just assign a fraction to each number and then randomly generate a number each time. And he was so frustrated because the computer couldn't beat that one.
Nice. I'm always amused by the idea of the rock, paper, scissors robot that learned how to beat people at rock, paper, scissors, which you would think is quite difficult because, again, it's just a choice of 3 different things. But what it actually was doing was using an incredibly fast camera to detect what they were doing and then putting out what really it was doing in response quick enough that you couldn't tell that it could just see what you'd done.
That's a good con.
Like, I guess only a computer could be that fast and react quickly enough, but they built it because, it's fun to build things. But they were obviously this is definitely cheating. But
right. Well, the cheating you get away with, is it really cheating?
Yeah.
I was just thinking. It reminds me. This showing fingers is there's a game called in my game theory notes in my module, it's called Evens and Odds. I don't know if that's its proper name. And each player shows either 1, 2, or 3 fingers. And if the sum of fingers is even, then player 1 wins, and otherwise player 2 wins. So if you both show 1 finger, it's even, but if one person shows 1 and the other person shows 2, then the other player wins, and all that. And it's one that I have in my class about games in equilibria and things like that. There is an equilibrium so that one player, in fact both players, should show 1 finger 7/12 of the time and 2 fingers 5/12 of the time, and even so it favours player 2. So on average they take a 1/12 of a point off player 1 each time they play.
Oh, interesting.
So
really? Wait, I would think it would be because it's just 1 and 2. Oh, it's 1, 2, and 3.
Yeah.
But no one uses 3. Does anyone use 3, or does it?
You got 1, 2, or 3, but it's got to be even or odd, right? So player 2 wins on odd.
Huh.
I think you can draw out the square. It's like a 3x3 square of what you get if you get 1, 2, or 3 on each side, and obviously there are 9 spaces in that, more than half of which are one of them, whichever one it is out of odd and even that there are more of. It's like 4 of one and 5 of the other. So there is an advantage for whichever player is that thing.
That's right. There are more options for one player. Yeah. Yeah, but some games there are more options for one player, but you can offset that by, just not choosing.
Yeah, well, that's the thing. You're not going to pick a column that's got 2 wins for them and 1 win for you. So you're obviously going to pick the other column. But then they know that you're obviously going to pick that column. So they're going to pick the thing out of that column that makes them win. So.
Yes. Yeah. Hello, game theory. Yes.
Right. It is, but the thing I like about game theory too is that the solution is always, especially for simple elementary games like these, it's to randomize, right? You're gonna pick some mix of strategies with certain probabilities, and you're gonna randomize. But we're so bad at it, we just can't randomize. Like you try to, and then you fall into a pattern. You think you're randomizing, and you're not. It's like just a weirdly hard thing, right? There's the famous study where people try to generate random coin flips, just write down heads, tails, heads, tails, 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 heads.
Yep.
And like we can't do it. We don't include long enough streaks.
Yeah.
And so any good computer can tell genuine randomness from human generated fake because it just doesn't look like real randomness.
I mean, it may be because so many people use the word random to mean something that isn't actually random. There's this sort of cultural sense of what the word random means, and actually it's like the iPod shuffle thing, right? That they had to make the shuffle program on the iPod be less random because everyone was like, it keeps playing 2 tracks by the same artist, and mathematicians are like, welcome to random. Like, this is what you need. This is how random works.
That happens to me too. Whenever I put a playlist on shuffle, I'm like, there's structure here. I can tell what's going on. You're trying to pull this on me. No. I see why you put those songs together. And like I cool down, I get out of the car, I take a few breaths, and like I know it's actually random, but I just can't. Every time I get caught up in the conspiracy theory.
Okay, so I don't know if you said the title of the book, but anyway, could you say the title of the book and tell people where they can find out more about it?
Yeah, this is a very good plan. It's good marketing there. So the book is Math Games with Bad Drawings. You can find it anywhere books are sold. It should be available. And then my website is mathwithbaddrawings.com, so you can find out more about the book there. And I'm on Twitter at Ben Orlin.
Cool. We are also on Twitter. I'm at Stex.
I'm at Peter Ollett. The podcast itself is at Maths Object.
And both Peter and I blog at a website called aperiodical.com, which is where you can find more episodes of the podcast.
And if you have any thoughts or any suggestions, or you'd like to tell us a game we should be talking about on this podcast, you can email objects@aperiodical.com.
The music is Funky Game Loop by Kevin MacLeod, licensed under Creative Commons.
Yeah, I feel like you guys say you'd like to keep them a little shorter than this. So yeah, I feel like this is.
I keep telling people it's a 15-minute podcast that just doesn't know it is. We keep running over.
Yeah.
It's a 35-minute podcast that thinks it's a 15-minute podcast.
That's fair. It's like the Douglas Adams book, right? The 5th book in the increasingly inaccurately named Hitchhiker's Trilogy.